Hello everyone, welcome to add-on. So we have to solve this question based on four-stroke engine, where we have that the stroke of the engine is 90 mm and the bore is given as 100 mm. So bore is nothing but the diameter of the piston, and stroke is nothing but the stroke length, or the difference between TDC and BDC. So the clearance volume is given as 70 cc, which is where the combustion of the gases will happen, and the engine works on Otto cycle because it is so we know that it is a petrol engine. So we have to determine the theoretical efficiency of the engine. And for the Otto cycle, we know that efficiency is nothing but 1 minus 1 divided by R to the power gamma minus 1. So this is the formula for efficiency for the Otto cycle. We have where the gamma is nothing but the isentropic coefficient, and R is nothing but compression ratio. And isentropic coefficient is 1.4 for air, ideal gas. So you do not have to find that. But the only variable here is the compression ratio to find the efficiency. So from the given data, we need to find the compression ratio. And if you look in an engine, so this is the clearance volume which will be there. And let us say this is the piston. And from TDC to BDC, you have something called as a swept volume. So so if your piston is at BDC and it travels and compresses the air until TDC, so the volume which it will like cover is called as the swept volume. So for that you can have the definition of compression ratio is nothing but the volume before compression and volume after compression. So before compression is nothing but swept volume plus clearance volume, and after the compression it will just be the clearance volume, as you can see from the illustration, which is nothing but like the before the compression the piston will be somewhere here. So the volume in the cylinder will be volume swept plus volume like the clearance. But after the compression, it will reach TDC, and only the volume will be remain as volume clearance. So this is how we can define the compression ratio. So if you calculate R from this, you need to calculate R from this. You have clearance volume is not given. Also the swept volume is not given. So yeah, clearance volume is 70 cc, which is given. So we need to calculate only swept volume. Swept volume can be calculated using this 5/4 into T square into like L, which is volume of any cylinder. If you consider engine block as a cylinder, then if you have the bore of the piston and you have the stroke length, then you can calculate the swept volume using this formula. So this is swept length and this is the diameter, which is also bore diameter. So you can calculate the swept volume from here, such as pi/4 into let us take D as a 10 square into L, which is stroke, as 9. So both of them are in centimeter now. So cubic centimeter will become your unit from the V stroke, because the clearance volume is given in the cubic centimeter unit only. So let us calculate this. We have pi divided by 4 into 100 into 9, 706.85. So 706.85 will become cc will become your shaft volume. So you can calculate R as 706.85 plus 70 divided by 70. So we have 11 as our compression ratio. So you can use this compression ratio value and calculate the efficiency using the formula, which is given upwards. So this is the formula which we will be using now. We have efficiency as 1 minus 1 divided by 11 to the power 0.4, because the value of gamma is 1.4. So we will have 11 to the power of 0.4, 1 divided by that, and 1 minus that, we have 61.6% as the engine efficiency. So this is how you can calculate engine efficiency in this particular question. Thank you.